Close your eyes for a moment and imagine looking at Saturn through a space telescope. A pale golden globe, wrapped in a thin, luminous disk that almost seems too delicate to be real. For centuries, we have drawn Saturn as a symbol of order and perfection. But as our spacecraft moved closer, a different story emerged. A story of shattered moons, invisible storms, and a giant world that is slowly rewriting its own appearance. Saturn's rings look like a solid halo, but they are really a vast field of icy rubble. Each point of light is a fragment of something that once was whole. The leading idea among scientists is that long ago, Saturn had at least one extra icy moon, orbiting too close to survive. Over millions of years, the planet's gravity pulled this moon inward, stretching it until its own gravity could no longer hold it together. At a distance called the Roche limit, the moon was slowly torn apart. It did not explode in a single instant, but crumbled into enormous blocks of ice and rock, releasing an unimaginable mass of material into orbit. Those shattered remains began to circle the planet, grinding themselves down through countless collisions into the fine, bright rings we see today. When we zoom in, the rings reveal an intricate architecture. Most particles are made of water ice, some purer than fresh snow, ranging from tiny grains smaller than sand to chunks larger than houses. They constantly collide, stick, and break apart again, creating patterns that ripple around the planet. Hidden among these fragments are tiny moons, called shepherd moons, that patrol the edges of the rings. Their gravity sweeps up material, opens narrow gaps, and carves sharp boundaries, much like a sculptor using invisible hands. The result is a structure so thin and so carefully layered that if you compressed all of Saturn's rings into a single block, it might be no larger than a small moon, yet it stretches across hundreds of thousands of kilometers. Saturn's rings feel timeless when we look at them, but they are not permanent. The ice grains that form them are slowly falling. Some are dragged inward by Saturn's gravity, spiraling down like a soft, invisible rain of charged particles and water into the upper atmosphere. Others are nudged outward or captured by small moons, gradually thinning the rings. On the scale of the universe, this ring system may be just a temporary phase in Saturn's life. There was a time before the rings existed, and there will be a time after they fade. We are living in the brief window when the solar system happens to include a ringed giant that is at its most spectacular. To understand this fragile system, we needed more than telescopes. We needed a visitor. That visitor was the Cassini spacecraft, built by teams across the world and launched at the end of the 20th century. After a 7-year journey, Cassini slipped into orbit around Saturn and began a patient, detailed survey that lasted more than a decade. It flew above, below, and even through the rings, measuring their composition, their temperature, and the way they respond to Saturn's magnetic field. It watched storms forming on the planet, mapped its moons in high resolution, and sent back a continuous stream of data that scientists are still analyzing today. One of Cassini's most surprising discoveries did not come from the rings themselves, but from a small bright moon called Enceladus. From a distance, Enceladus looked like a simple frozen world. Up close, Cassini discovered fractures near its south pole where plumes of water vapor and ice crystals were erupting into space like geysers. These jets are powerful enough to escape the Moon's weak gravity and spread out around Saturn, forming a vast, faint ring that is almost invisible in normal light. Inside those plumes, Cassini detected water, ice, simple organic molecules, and hints of salts, signs that beneath the ice crust of Enceladus there may be a global ocean in contact with a rocky seafloor. Saturn, a gas giant with no solid surface, hosts a tiny moon that could be one of the most promising places to search for life beyond Earth. Far above the rings, Saturn's atmosphere hides another mystery. A storm shaped like a perfect hexagon. At the North Pole, a powerful jet stream circles the planet. But instead of forming a simple ring of clouds, it twists into 6 straight sides, creating a dark, rotating honeycomb with a spinning vortex at its center. This structure is larger than Earth and remarkably stable. Observations over decades show it persisting as Saturn turns and its seasons slowly change. Wind speeds there can reach over 1,000 kilometers per hour, yet the overall shape remains sharply defined, as if the atmosphere itself has locked into a giant rotating pattern. To understand why Saturn can host such unusual storms, we have to look beneath the clouds. Saturn is made mostly of hydrogen and helium, the same elements that power the Sun, but at much lower temperatures and pressures. Near the top, hydrogen behaves like a gas, forming bands of clouds that we can see. Deeper down, the pressure becomes so intense that hydrogen is squeezed into a liquid, and even deeper it may transform into a metallic state that can conduct electricity. At the center, there is probably a dense core of heavier elements, rock and metals, surrounded by layers of hot, compressed material. Heat leaking out from this interior, combined with rapid rotation, drives powerful winds and storms in the outer atmosphere. The hexagon at the pole might be the visible expression of deep flows that we cannot see directly. Patterns formed where rising and sinking currents meet under conditions that are extremely difficult to reproduce on Earth. Saturn also experiences seasons, but on a very different timescale from our own. One Saturn year is almost 30 Earth years, so each season lasts more than 7 Earth years. As the planet orbits the Sun, different hemispheres receive changing amounts of light, slowly altering the chemistry and color of the clouds. Images taken years apart show the polar regions changing hue, from deeper blues to more golden tones, as sunlight triggers the formation of haze particles high in the atmosphere. In this slow dance of light and shadow, even the hexagonal storm changes its appearance, reminding us that what looks permanent in a single image is often just a moment in a much longer story. After many years in orbit, Cassini's fuel reserves were gradually running out. To avoid the risk of the spacecraft accidentally contaminating one of Saturn's potentially habitable moons, mission planners chose a carefully controlled ending. They guided Cassini on a series of dramatic orbits that threaded the space between the inner rings and the planet's upper atmosphere. During these final passes, the spacecraft collected unique measurements of the ring's mass, Saturn's gravity field, and the structure of its atmosphere. Eventually, it dipped too deep. Saturn's thick air pulled on Cassini, heating it up and tearing it apart. The last signals from the spacecraft reached Earth as a faint whisper, traveling across more than 1 billion kilometers, and then it was gone, its atoms becoming part of the planet it had studied for so long. Saturn is more than a beautiful picture in a textbook. It is a laboratory for understanding how gravity shapes matter, how atmospheres behave under extreme conditions, and how moons and rings can interact in subtle ways. It shows us that even within our own solar system, there are phenomena that we are only beginning to understand. The rings remind us that cosmic beauty can be born from destruction. The hidden ocean of Enceladus suggests that quiet, icy worlds may be more active and more interesting than they appear. And the hexagon at the pole challenges our intuition about how storms and fluids should behave on a rotating planet. Today, no spacecraft orbits Saturn. Cassini's mission is over, and future missions are still being designed and debated. Yet, the data it sent home continues to reveal new details, as scientists find patterns that were not obvious at first. Each new analysis raises fresh questions. How exactly did the rings form? How long will they last? What is happening in the dark seas beneath the ice of Enceladus? In astronomy, endings are rarely final. The story of Saturn did not stop when Cassini burned up. It simply changed form, from images on a screen to equations on a page, to new ideas in the minds of people who are already planning the next journey. When we look at Saturn, we see both fragility and power. A giant world light enough to float in water, wrapped in rings made from the ruins of a lost moon, circled by icy worlds that may hide oceans. In the silent darkness of space, Saturn spins on, its storms and rings slowly evolving. And somewhere, perhaps on a future spacecraft, a camera will turn toward it again, and we will add another chapter to this quiet, extraordinary story.